On the other side of the world is the harsh west coast of New Zealand's South Island. A team of 5 scientists are on a mission to solve a series of science challenges. Their base camp is an old sawmill. Their ultimate challenge is to find gold and make a pure gold souvenir. But this time they're on a special mission, something very different and very dangerous. Our scientists are Mike Bullivant, our creative chemist. He's also a stand-up comedian and a keen outdoors man. Kathy Sykes, an irrepressible physicist and extreme sports fanatic. Mike Leahy's a biologist with attitude. He's also a car mechanic and martial arts expert. Ellen Macaulay's an intrepid botanist from Missouri, whose second home is the Amazon jungle. Jonathan Hare's a physicist with a science brain and an artist's eye, a true Renaissance man. And me, Kate Humble, the odd job girl. Together we are Rough Science. This week, our team face one of nature's most awesome, beautiful and dangerous creations. A river of ice, a glacier. This is the Franz Josef Glacier, one of the fastest moving in the world. Experts claim it's in retreat, that it's melting faster than it's moving downhill. It's only 5 miles from our base camp, so naturally, it's an irresistible challenge to our scientists.
This week, we're going to have an expedition. We're going to go and explore the massive Franz Josef Glacier, which is over there. Yes. And so, over the next 3 days, you've got some discoveries to make. Jonathan, Kathy and Mike, we want you to try and find out just how quickly that glacier is moving. And Mike, B and Ellen, can you try and establish how fast it's retreating? How fast is that ice melting? Okay. Now, of course, knowing you lot, you might do that very quickly. So can you use your collective science nous to come up with some neat ideas of keeping us warm, portable ideas, things that don't involve half a tree and some firelighters? So you've got all the tools and bits and pieces that you can find in the sawmill and obviously natural resources that you can put to use and anything you find that might be useful in there. You've got 3 days.
To solve the challenges, the scientists are going to have to build their own apparatus using the gear in the sawmill, and the trunk contains a surprise kit. It might give the scientists added inspiration. So, using only what's at hand, the team must use their ingenuity to work out how fast the glacier's retreating, make portable heaters, and measure the glacier's speed of flow. So, Kathy, short of building a speed radar gun, how on earth are you going to measure how fast this glacier is moving?
OK, well, if you imagine, here's some rock.
Yeah.
And here is the glacier, right? And the glacier is moving that way, and we're staying still on the rock, and we want to measure that speed. What we're going to have to do is to go along here to the edge, and then we're going to go along here and measure out very, very accurately a particular distance, and then put in our other point.
OK.
And this is what we call our baseline. And this distance here is something that we have to know very, very well.
Right.
OK. And then what we do is we're actually just going to wander out onto the ice and ram a stake in somewhere around there. And then we're going to just measure out the angles, so do a sighting from here to here. Measure this angle. And then we wander up here to the second stake.
Yeah.
And then do the same thing from here to here again.
Yeah.
And measure that angle.
Right.
Then we've done our business for the first day.
OK.
Now, overnight, I hope, the glacier's going to move downhill, shooting off that way.
Yeah.
And we go out here in the morning, and we do the same measurements again. So we just go from there to there, and then from there to there.
Yeah.
We measure these angles. And you can see that there's now been a change in angle.
Right.
So we'll be able to work out, using trigonometry, how much this thing has actually moved.
Right.
Now, the catch is, though, that that movement is probably tiny.
Yeah.
And we're only going to have probably 24 hours to do it over. So we're trying to measure tiny, tiny changes. So we've got to measure these angles as precisely as we can, and we still may not actually be able to measure that change.
OK. Mike, Al and Kathy get on with making the equipment they're going to need to measure the speed of the glacier. And Jonathan's got the tough job of sorting out how to measure those tiny angles. He's making 2 of the biggest protractors you're ever likely to see.
So what I've done here is I've worked out using simple maths the radius required so that the distance all the way round is 180 centimetres. And of course, it's half a circle, so that's also 180 degrees. So in that case, each centimetre is exactly 1 degree, but using the millimetres will give me tenths of a degree. So it's a really convenient way of making an easy, accurate protractor. But of course, the only problem is it's rather large.
I think the challenges are quite hard this time, so we've all been full on, really. I do like working with people. I like being part of the crew and the team that are doing things. But sometimes, if I'm working something out, well, I've got to go completely from scratch and use the materials available. There's a lot of time just thinking about how to use what I've got for the best. And sometimes it's quite difficult to think as well how I would talk to other people and discuss it. You know, there's a bit of me that would just go off and do it, and I have to sometimes remember to stop.
No, I think we've got to meet one of these.
It's important to chat to the others.
Yeah, have a look. Have a look.
Jonathan's protractors are absolutely enormous, and that might make working with them on the glacier very awkward.
I think this is going to be a bit of a challenge to try and actually do this. As far as the science goes, I have no idea until we get there how it's going to turn out.
Mike B and Ellen's challenge is different from the other teams. Is the glacier melting faster than it's flowing downhill? If it is, then the front of the glacier will move backwards and they need to measure by how much. Their device is simple: half a picture frame, a broom handle and a few nails, but they've got no idea if it'll actually work. Ellen and Mike must get to the front of the glacier, so we're trekking across the floodplain created by the melting ice. Everywhere you look, you can see signs of the glacier's immense power.
Look at the trees.
Yeah.
Did you see how they're all really, really short and all of a sudden they get really, really big?
Yeah, there's quite a distinct line across there.
Yeah. Well, what's happening is the glacier must have been up to that tree line. So the forest started with those tall trees. And everything else was below the ice.
And Ellen's point is proved by this painting of the glacier by the explorer Sir William Fox 130 years ago. Today, it looks very different. So, in the past, the glacier has retreated. But is it doing so now? And if so, by how much?
Oh, it's much colder up near the glacier, isn't it? I can't believe it.
I can see why we've been given the challenge of building a portable form of heating.
Absolutely.
Now, if you look at this whole thing, this entire place is the terminal face. That's the end of the glacier.
It seems so weird to me is that you have this massive kind of wall of ice and then no ice at all.
Yeah.
Well, one thing that's patently obvious is that this glacier is melting.
But what we're looking to see is the ice melting faster than the ice is moving forward.
And if the answer to that question is yes, it is melting faster than it's moving forward, then it's effectively retreating.
Right.
Exactly.
Exactly.
So is this where the broom handle and the half a picture frame comes in? Got it. Okay. This I have to see. How's it going to work?
It's very crude. We'll position this broom handle against the face. We'll mark this here, the base of it, so that when we come back in on day 3, we'll be able to place this in exactly the same position. We'll put a nail in here, hold it up at the same inclination, and a nail in here, which is in contact with the face.
Right.
So when we come back in 2 days' time, if the glacier has retreated, then there'll be a gap between the front of the face and the nail.
So you simply just make that measurement and that will tell you whether it's retreated or advanced over the next couple of days.
It's a very crude device.
But it should work, shouldn't it?
Well, I hope so.
The other team want to go up high on the glacier to measure its speed. And to keep warm up there, Mike L has a cunning plan: to use ice to make fire.
Right, this is our smoker or tea hut. What I'm hoping to do when I get up the glacier, because one of the challenges was to try and stay warm, is make an ice lens. And that way it'd work like a magnifying glass, and maybe we could set fire to some tinder or some wood or something. But it's not as easy as just cutting some ice out of the glacier, because that'll be crystallised and, you know, dull. A little bit like ice cubes straight out of the freezer. So what I've got to do is boil this water for quite a long time until I've got rid of all the dissolved gases. Then put it in a sealed bottle and I should be able to make a clear lens.
It's late afternoon and Kathy, Jonathan and Mike want to test their speed measuring kit before tomorrow's challenge on the glacier.
So this is lined up with that one's lined up with this one. So we've got the baseline sorted.
So, Mike, you see that flag?
The one in the middle?
Venture onto the ice.
If you, very carefully, venture onto the ice.
Venture onto the glacier. Oh, nightmare. I'm not wearing any spikes.
Yes, you are. I can see them.
Oh, right, I've got my spikes on now.
You've got spikes on.
Okay, but take it
Take care.
Whoa.
Take care.
There's a big crevasse.
You got the radio? Mike, can you hear me?
Okay, that'll do nicely.
Yeah, be careful, it's icy.
Now they can take their bearings from the tripods to the flag, just as Kathy explained earlier.
It was cold out there, I came back.
So it's 135.2.
Should we do the acute angle? Just measure that one.
Okay. So that's, oh yeah, that's right. 44. 0.7.
Now we take the piece of paper.
Yep, I'm gonna go over there.
You're running over there.
Looking at these tripods, I hope it isn't too windy up the glacier.
So do
The
I.
paper's
do
not
I.
going to be the problem, is it?
That's 67.3.
So the glacier's moved now.
Yep, right.
A night has passed.
And I've got to go back out there again.
And you've got to go out there again.
Hey, mind the ice.
And with the new readings, they can work out how far the hypothetical glacier has moved.
So what have we got, Kathy?
Let's get that right out of the way.
That looks a bit big, actually.
It does a bit, doesn't it? It's just about 3 metres.
3 centimetres, which is equivalent to 3 metres, isn't it?
Yep.
And 3 metres looks quite close to the distance between Mike's flags.
How much is it, Mike?
1.6 metres.
Shut up!
It is about 3 metres 28.
Oh!
The team's practice measurement was pretty accurate. But tomorrow will not be that easy. The glacier's a slippery, crevasse-ridden place to work. It's not as flat as the sawmill's yard. In the evening, the mood is subdued. And for the first time, we could be missing a scientist from a day's filming. Ellen has a bad cold and retires to bed.
I've just made Ellen a cup of tea because she's not very well. She's got some sinus problems. I don't even know her then, because she's American, she'll want tea. But I haven't got any coffee. I'll brought you some tea.
Oh, you're so sweet.
Right, protractors. Yes. Ruler. Yes.
Day 2 and Kathy, Mike, Elle and Jonathan are preparing their bits and pieces before they fly up to the glacier to begin their measurements.
And this is a masterpiece of contemporary engineering.
Hopefully they'll come back with some results. Ellen's come down with a streaming cold, which leaves Mike B cooking up concoctions in a desperate attempt to keep us all warm. So what are you going to do today, bereft of Ellen?
I'm going to explore some chemical reactions that generate heat.
OK,
But
so
like-
this is in our attempt to have portable sources of warmth.
Exactly. I mean, the easiest thing would be give you a flare, you know. But you want something safe that I could put in these bags, for instance. Just chemicals that you can mix together that, when they react together, will generate warmth.
And whilst Mike B makes chemical heaters to keep us warm, we're looking for somewhere to land the survey team. We're going to have to trek across the glacier and find solid ground beside it to set up the tripods. With Ellen recuperating in bed, Mike B's left to his own devices. He's testing the ingredients for hand warmers to use on the ice, and he's making a bizarre bid for his own cookery show.
I'm going to be making lime from chalk. Now, I've used red, gold and green chalk, which is a Jamaican variation on the recipe, but you can use whatever chalk you want. Grind the chalk up to a very fine powder, a little like flour. Get it to a nice consistency. And then we'll scoop some of this out onto a plate. And we put the plate in a very hot oven. It has to be very hot, nothing less than regular 8 for 2 hours. And that process will convert all of this chalk into lime. Of course, I don't recommend you do this yourself at home, as the lime we're making is a very dangerous chemical.
Welcome to the glacier.
Chris Morris, our alpine guide, is here to help us novices negotiate the glacier and, well, basically, to keep us alive.
The three things you need to remember, you might joke about this, but it's actually the BBC. Balance, boots and confidence, okay?
The surface of the glacier is very wet and slippery, so normal boots don't grip. Chris has given us special glacier boots. These have steel teeth on the soles that bite into the ice, providing you stamp down hard enough.
You okay, Kate?
First one down the crevasse. Oh.
Oh, look at that. All the chalk has turned to lime. And put a sprig on there. That'll look good on any table.
Mike's lime is now ready to test for its power as a hand warmer.
Now, here we are. I'll just put some of the lime into the bottom of this flask. There goes the thermometer. And the second ingredient is just water. Simple water. Let's see what happens when we add the water. See what effect that has on the temperature. Well, it's shooting up. It's shooting up, yeah. It's 41 at the moment. Well, what we're actually doing is slaking the lime. It's a process called slaking, and it just forms calcium hydroxide. That's a pretty good recipe for a reaction that gives out of a lot of heat. Well done.
It takes us hours to find a way off the glacier. With no clearly defined edge, finding flat, solid ground to set up the tripods is proving very tricky. There's loose rock lying on top of the ice all over the place.
Well, I have to say, it certainly is a far cry from your neat little diagram when you see it for reality, isn't it?
This is difficult terrain. And, you know, what we wanted was a really flat bit and then a bit of ice to go to. And what we've got is this huge, huge rocky bit. So we've got a 50-metre length of string.
Right.
So we can measure out our baseline.
Yeah.
It's at a bit of an angle, but that will probably be okay. And I just need to get out up there somewhere and put up one of the flags.
Great. It's good fun.
Yeah,
Good
scary fun.
Guys, is this exactly 50 metres, this piece of string?
Yeah, the last little yellow bow is exactly 50 metres.
Okay. There you are, there's 50 metres.
Mike's getting more ambitious in his search for something to keep us warm.
Now, my final recipe today is a real vindaloo of a chemical reaction, something for, you know, the spicier taste. We've got some ground aluminium, which I've made from this drinks can here, and I've put that in the container there with some rust, which I got from this shed to my right. Any shed will do, as long as it's rusty. We've mixed the two ingredients to a fine powder, and I'm going to put them on this rock, and on the rock are two separate pieces of steel. And I hope the heat generated by this reaction will weld these two bits of steel together. It should work because this reaction was used to weld railway lines together in the past.
Here we go.
Great.
There's your protractor.
Cool. Fabulous. Just want
That's
a tight
fact
fit,
you've
isn't it?
got all the holes pre-drilled. That's brilliant.
Lovely.
Well, Kathy's getting pretty close to the top now, so hopefully we'll be able to do a sighting.
Yeah. Now all we have to do is line that up to our flag, which is easier said than done.
Yes, it's quite a steep angle, isn't it?
Yeah, also it's a long way off.
78.5, exactly, Jay.
And if we rush off to the next one and
Yeah.
draw the similar line that we get the angle from that one,
Yeah.
where they cross,
what we'll get is a scale drawing of the actual real thing.
Brilliant. Come on then, let's go and do the other bearing.
Okay.
The powdered aluminium removes the oxygen from the rust, leaving molten iron, which welds the plates together.
Let's see what it's done. Let's see if we can break. I can't break them off. It's welded to the bottom of that iron container.
And we line that up with the flag. Yeah, that's okay. And I draw the line.
Yeah.
82.4 degrees.
And so you just now have to repeat this tomorrow?
Tomorrow, hopefully in roughly a day's time. And that place should shift. And the shift will give us how much it's moved. And then that will give us the speed of the glacier down the valley.
Good day's work, guys.
Yeah.
Well done. It's the end of day 2. Tomorrow we can measure the glacier's speed, so now it's time to make fire from ice. Michael, Jonathan and Kathy fly up to a mountain hut. It's high enough that they can freeze Mike's special gas-free water.
Right, I'm going to try and make an ice lens traditionally, just using boiled water in a dish. But the problem is you can't get a biconvex lens, that is a bulge either side. So I'm not sure how well we can do this. Anyway, I'm carrying on with this idea, but in the meantime, Kathy here, I think, has come up with the ultimate solution.
I filled up the balloon with water, put a ring inside, and so it's kind of bulged out and formed a nice curve on each side. So hopefully that'll form almost a perfect lens tomorrow.
And it's absolutely perfect idea. I don't know why people don't put it in the survival books,
Well,
you know?
but it may not work, Mike.
I don't know. I've got a good feeling because it's the right shape from day one, isn't it? It's no carving in that.
No, it'll be a bit of a teardrop, but we can just carve it a bit, get it to the right shape afterwards.
So now we're high enough and cold enough, this is going to freeze.
Very
and when we
quickly.
get here in the morning, we'll have some ice lenses. Sort of.
With the others up the mountain and Ellen still poorly, Mike B's left all alone. A strange experience for him.
I've been working on my own in the sawmill all day. And as the other three are up in the mountains with Kate, it's been quite a lonely day. But I got such a lot done because there were no distractions. And the place was so quiet. It was almost as if, you know, I was the little schoolboy that they forgot at the back of the class.
It's early morning on our final day, and Kathy discovers that rubber is an extremely good insulator, even in sub-zero temperatures.
When I came to have a look at the balloon this morning, it hadn't frozen at all. So I've had to resort to something a bit more drastic. If you add salt to a mixture of ice and water, you can really lower the temperature. This might go down to something like -10 or even -15. And that's just because salt acts as an impurity, and that kind of lowers the freezing point of this whole mixture. And I've dunked the balloon in, and I'm hoping that's going to freeze it before we have to leave.
Right, this is the ice that we got out of the small dish last night. But for some reason, as you can see, it's not perfectly clear in the middle. There must have been some gas molecules in there. Even so, it's not working too badly, so I've cut it to a lens shape. Not quite there yet. We're trying to see, with very little sunlight, whether it's actually working like a magnifying glass. So you can see there's a bright point in the middle, so it is working as a lens.
Does it feel warm?
Yeah, does that feel warm? Can you feel it at all, Jay?
Well, I'm not sure if it's my imagination or not. Yeah, a little bit.
You can feel, but it's nowhere near enough to set fire to a piece of
No, I
kindling,
wouldn't
is it?
have my hand here, would I?
Whoops. Hey, that looks okay. See the little ring? Well, it's a really nice lens shape, but it's not very clear ice.
So without their lens, our team returned to take the crucial repeat measurements to calculate the glacier's speed. How far has our flag moved?
Mike, if you could shout out the angle when you were there.
79 dead, 79.0.
Right, I'll go work it out from the trig.
Okay.
And you'll measure it off from
And
there,
we
yeah?
can compare it, yeah.
Brilliant.
See ya. Okay, let's see what we've got then. Can you read that off, Mike?
Yeah, I reckon that's just about 2 millimetres.
So on this scale, that should be about 1 metre of movement then.
Mike and Jonathan have a rough answer. Kathy will give us a much more accurate speed using trigonometry.
OK, guys, what did you make it?
About a metre a day.
About a metre?
Yeah.
Brilliant, brilliant, because I got about 1.3 metres in a day. So, yes, it's the same at least.
So now we know how fast the glacier's flowing downhill, but is it melting even faster than it's moving? If it is melting faster, then the glacier will have shrunk at the terminal face. To find out, a fully fit Ellen rejoins Mike B.
Do you think you're going to get some results?
Well, I hope so, but I've no idea which way it's going to go. That is the same place as we had it.
So the blue marks are still there.
Yeah, we're assuming the bedrock hasn't moved. And look at that.
Good assumption.
Yeah, look at that. That is the amount that is melted over 2 days, which is,
Okay.
what, 60, 70 millimetres, 60,
Let's
70
check.
centimetres?
Spot on, I make that 7.
What we can say is it's melting, definitely,
Yeah,
but it's melting faster than it's advancing.
so it's effectively retreated 7 centimetres in 2 days.
Yeah, in those 2 days, yeah.
So you've got your results.
Yeah.
So it's the end of day 3 and time for the Rough Science clan to gather, check our results and test Mike B's hand warmers.
Whoa! Now then, over the last 3 days you've all got to know this glacier pretty well, I think. So, Mike and Ellen, first of all, is it retreating?
We work out that it's retreating by about 6 or 7 centimetres.
Over how long?
2 days.
So about 3 a day.
Okay.
3 or 4.
All right. And Jonathan, Kathy and Mike, what did you discover?
It moved about 1.3 metres, that particular bit of glacier that we were looking at in a day.
Okay, well, I have here a letter from Brian Anderson of the Department of Geography at the University of Canterbury, Christchurch, New Zealand, and he says, "Dear rough scientists, I've been recording the speed of the Franz Josef Glacier for 2 years using the latest satellite technology." Little different from yours. I estimate the ice moves at 50 centimetres to 1 metre per day. So pretty good.
Wow!
And at the terminal face, the glacier is indeed retreating at about 5 centimetres per day. Now, just the little question of keeping warm. Mike, you cooked
is
up
Mike.
a concoction yesterday.
Yeah, well, if you dish
What do you
these goodie
reckon?
bags out,
Okay.
this is a reaction that's going to generate a bit of heat, a chemical reaction. Yeah, it's got lime in it. We made some lime from chalk. So if I just put a drop in here, all you need to do is squish it about until it's a paste.
Yeah.
It's warm!
Concrete does this.
Oh, that's great.
Oh, you've got a bit too much in there.
nice.
Hey!
Don't get it on your hands. It's heating up.
Wow!
That's
I'm
amazing.
impressed.
Hands on fire. Are you sure you're not been making bombs? Look at that one.
It'll last for a few hours.
I tell you.
Finger burners, fantastic!
That's steam coming
It's
up.
melting the plastic. Oh, yeah. Look at that. Holes in it.
Congratulations. Well done, all of you. And we'll see you next time on Rough Science.
Next time, the pressure is on. It's our team's last chance to find enough gold to complete their ultimate challenge to make a gold souvenir. Ellen and Jonathan go on a treasure hunt. Kathy tries gold mining on a beach, whilst the two Mikes turn to alchemy with a baked potato. For a free Rough Science booklet and details of Open University programmes, call 0870 900 9581 or log on to www.open2.net, where you can also enter a competition to win whatever the scientists make out of their gold at the end of the series.